So now I'm going to show you how to compute the average rate of change from an explicitly defined function. Here we have three functions specified by formulas. So for each one, I'm going to compute the average rate of change of a given f of x from a given value of x1 to a given value of x2. So for the first one, the average rate of change, I'm going to denote by m because the average rate of change is the slope of a line connecting the points in the graph of f of x at x1 and x2. So that slope is a change in y values, y2 minus y1 over x2 minus x1. But our y values are specified by f of x. So y2 is f of x2, y1 is f of x1. We're still dividing by x2 minus x1. Now if we fill in our values of x1 and x2, we have f of x2, which is 6.2, minus x1, which is f of 4.6, divided by x2, 6.2, minus x1, which is 4.6. So now we need to plug these values into a function, 4.6 and 6.2. Now, we need to be very careful here because we are subtracting, and therefore it's a good idea to put these function values in parentheses. So I'm going to do that at the outset. So f of 6.2 would be, based on the formula for f of x, minus 3, 6.2 cubed, then minus x squared, so minus 6.2 squared, and then minus 4x, so minus 4 times 6.2, plus 3. And then I subtract off the value of f of 4.6. And notice I close the parentheses for f of 6.2. So all of this is f of 6.2. And now I'm going to have f of 4.6 here. So that would be minus 3, 4.6 cubed, minus 4.6 squared, minus 4 times 4.6, plus 3. And all of this is still divided by the difference in x values, 6.2 minus 4.6, which happens to be equal to 1.6. Okay, so now I need to work all these out. So at this point, we definitely need our calculator. So 6.2, the recording got cut off, so I'll just pick up from where I left off. So here I have everything written out like you would enter it into a calculator such as a TI-84. I'm just using an iPhone calculator here, so it's a little more laborious. So I'm going to have 6.2 cubed times 3 so it's minus 714.984 minus 6.2 squared, so that's 38.44, and then 6.2 times 4, I'm going to double it twice. So 6.2, you double it, you get 12.4, you double it again, and you get 24.8, and then plus 3. And then for f of 4.6, I'm going to have, so 4.6 cubed, and then times 3, minus 3 rather, so I'm going to have minus 292 292.008 minus 4.6 squared, which is minus 21.16, and then 4.6 times 4, I'm going to double it twice, so 9.2, so 18.4, plus 3 all over 1.6. So now when I work out all of these, see why I put the parentheses here? This minus has to be distributed through here, so these minuses will end up becoming pluses. So I'm going to have minus 714.984. Now, for this problem, we want to get our final answer rounded to the nearest hundredth, but I'm actually retaining more decimal places than that because if you round off too soon, you might lose information and throw off your final answer. So I recommend keeping more decimal places than necessary during your intermediate steps. Okay, so I have minus. Sorry, hit the wrong button here. Minus 38.44 minus 24.8 plus 3. So we have minus 775.224, and then working out what's in parentheses here, I have minus 292.08 minus minus 21.16 minus 18.4 plus 3. So I have minus 328.568. So this minus and minus gives us a plus. So okay, and all of this, don't forget, is divided by 1.6. So when we work out the numerator, we get minus 446.656 over 1.6. So we carry out the division, and we get minus 279.16. And that's our final answer for that one. Okay, now we do the same thing with two other functions that have different forms. So here we had a polynomial of degree 3, a cubic, but here we have a fraction, and then we have another function that's a square root. So for this function, we have our slope, as before, is f of x2 minus f of x1. So this slope is our average rate of change. So f of x2 minus f of x1 divided by x2 minus x1. We'll fill in our given x values now, they're different. So we have f of 2.2 minus f of minus 7.5 over x2, which is 2.2, minus 7.5. So minus and minus gives us a plus. Okay, now we need to substitute these x values into our function f of x. So we're going to have 3 over 7 times 2.2 plus 9 minus 3 over 7 times minus 7.5 plus 9. And then divided by the difference in our x values. So we have effectively 2.2 plus 7.5 because of the negatives canceling. So we end up with 9.7 down below. Okay. So now I just need to work out these two fractions. So at this point, we need to turn to our calculator. Again, let's retain somewhat more decimal places than we actually need. So I have 7 times 2.2 plus 9, 1 over x times 3. So this first fraction turns out to be 0.1 12295. I'm going to keep 5 decimal places. And then for this fraction, I have 7 times 7.5. That's negative, plus 9, and then 1 over x times 3 up top, and we have minus 0.06897, all divided by 9.7. So now, once we work this out, so I have plus divided by 9.7. And what I get to 2 decimal places is 0.02. Really, I get 0.01978, but to nearest hundredth is 0.02. Okay, for this last problem involving average rate of change for an explicitly defined function, we have f of x equals the square root of 3x plus 2, and x1 is 5 and x2 equals 9. So our slope m, which is the average rate of change from x1 to x2, is as before, f of x2 minus f of x1 over x2 minus x1. So let's fill in our x values. So I have f of 9 minus f of 5 over 9 minus 5. So f of 9 is the square root of 3 times 9 plus 2. And then f of minus f of 5, which is the square root of 3, 5 plus 2, all over 9 minus 5, which is 4. So now if we work out the values under the radical signs, so we have 3 times 9 is 27, plus 2 is 29, so square root of 29. And then 3 times 5 is 15, plus 2 is 17, so square root of 17, all over 4. So at this point, we need to turn to our calculator to work out square root of 29 and square root of 17. So 29 square root is 5 point, use 3 decimal places here, because we need to get an answer to the nearest hundredth. 5.385, and then we have 17 square root, so that would be 4.123. All divided by 4. So now we carry out the subtraction. So I have 1.262 divided by 4. So that would turn out to be 631. So 0.3 3155. That's the exact value of this fraction. But if I were to round to the nearest hundredth, I would get 0.32. So that is my final answer.